What are your team's goals?
Yes, the main one is obviously get into the European Rocketry Challenge. The team was quite disappointed last year to not get in. We think the main reason was a lack of ambition. So we've gone the other way this year. So we're aiming for 9,000 meters, which the team hasn't gone for in the past. We have our new hybrid rocket engine, which we have been designing over the past couple of years, tested it successfully at the Race to Space competition. So we will be entering the student designed engine 9,000 meter category. In terms of roadmap, we're currently in the sort of late stages of design. So the majority of the rocket is designed, but we're waiting for a few smaller things. So there's someone on the team doing engine cooling. There's a guy on the team doing like the plumbing for the engine that still needs to be sorted. Ben's working on the recovery system. But yeah, pretty soon we'll be in sort of full manufacturing swing, and then applying for EuRoC, hopefully get in, and then manufacture over the summer. Got quite a lot of testing to do as well, especially on the engine, as part of EuRoC and the Race to Space competition. So yeah, that's the sort of broad roadmap.
I guess our biggest medium-term goal is getting the engine built and test fired without any significant anomalies. At that point, a lot of the other challenges the team faces are relatively, in the context of rocketry, relatively conventional challenges. But having the engine work successfully without burning through our insulation, which was our major issue last year, is kind of the main goal for now.
That we did start manufacturing some small pieces. Like the airbrake systems, and we are getting prepared for the manufacturing of the fuselage.
We started manufacturing the airbrakes, which are actually almost ready for assembly. Similar for the recovery system, we just need a few more parts, and then Ben's going to manufacture the parachute himself as well. And we've started manufacture of the molds for the fuselage. So the fuselage is a composite fiberglass fuselage, so we're going to be laying up. We 3D printed the molds. We're prepping them to do that in the next couple of weeks. And then the other active projects, I guess, apart from the sort of the main structural design, is payloads, engine cooling, engine plumbing.
You said that you're making a hybrid engine. What is its fuel and oxidizer?
The fuel that we're using is a paraffin wax. We are also investigating the use of using beeswax. The university is really keen on green-based initiatives, and having a sustainable and renewable fuel like beeswax that the university really loves. So we're investigating that. And then our oxidizer is nitrous oxide.
A recent challenge is that our manufacturer for the fuel grains, the solid bit of the fuel, has pulled out due to time constraints, having to consider manufacturing our own fuel grains. So we're looking at building a centrifugal sort of spin casting rig that we use to cast our own grains. So that's, we just started working on that a couple of weeks ago, but hopefully we'll have that up and running soon so we can start manufacturing grains and test them at the Race to Space competition.
Well, almost all the EuRoC teams make their own grains.
Yeah, we attempted to cast our own grains last year, and we were going to fire them, and then we encountered those insulation issues, as I said before. But we found pretty significant issues with getting all of the air bubbles out. So
hence the move to spin casting,
which should be fine. It seems very feasible.
Other teams do it, so we don't foresee too many issues with doing that. The only reason is, last year we just bought the grains from a supplier, which just reduced some of the work required. But this year, we can't do that. So manufacture our own ones. That's fine.